Hi, this is the third partial project of Mathematics for Decision Making. The team is Regina Nogués, Valeria Jimenez, María Miguel Gracia, and Ana Paula Peñuño.
And well, according to the research we made, normal distribution, also known as bell curve or Gaussian distribution, is a continuous probability distribution that is symmetrical on both sides of the mean. So the right side of the center is a mirror image of the left side, and meaning that its probability distribution, that it's only dependent on the mean and the standard deviation. It's of great importance because continuous data can be represented in nature and psychology with these kinds of graphs. And well, regarding the characteristics of normal distribution, some of the characteristics are the mean, the median, and mode, which are all equal, and the variance, which is the average square distance from the mean, and the standard deviation that is obtained by the square root of the variance. Also, the curve is continuous and it never touches the x-axis, and its mode is symmetrical with the mean, meaning that it extends continuously all over the values of x. An important characteristic of these values from the vertical axis start at 0 and they go up from there. And this is a rule of probability. A normal distribution doesn't always give us a result probabilities.
Moving on to the standard normal distribution. The standard normal distribution is a special case of the normal distribution. Normal distributions don't always have the same means and standard deviations. A normal distribution occurs when a normal random variable has a standard deviation of 1 and a mean of 0, and then it's called standard normal distribution. The normal random variable of a standard normal distribution is called a z-score. Now we can see the table of z-scores.
Hi, I am Ana Pau, and I'm in the three scenarios that we have to calculate C values. So first, you have the first scenario where the value of C is greater than the value you are going to calculate. So you can see this example B, and what you have to do is that you need to check in the table the number, and then you're going to subtract 1 from this value, and you're going to have this probability. In the other scenario, you have where C where the value is greater than C, and it's where you only look the value at the table, and that's all. You only locate the number and you write it here. And then when you have an interval, so you need to look at the table. In this case, -2, you look at the negative side because you have two sides, as we mentioned previously, a negative and a positive. And then you look at the positive one, in this case 2, and after that you're going to subtract them and you're going to look the result and search for the value of C of the number it gives you. And now we're going to explain the problems and how we solve them and the correction.
So now I'm gonna explain part 4 of the teamwork. So in these problems, we have to solve for the question that's asked. So letter A asks us, what is the probability that the selected box weighs less than 500 grams? So we have here that the mean is 505 and the standard deviation is 15 and our x is 500. So the formula is x minus the mean over the standard deviation. So this formula will give us a value, and this value we need to look for it on the C table. And once we look for it in the C values in the table, we write that number down as the final result for our problem, which would be 0.33 0.07, which is equal to 37.04%. And that's how we solve for these problems. In number 2, we had these problems wrong. We have 2 squared down here where that shouldn't have been there. As you can see, the values given are these ones. So what we should have done is have this value minus the mean over the standard deviation, which is right here. This actually was correct. And then we should have looked for this value on the C table, and that should have been it. I don't really know why we did this 2 pi squared 2 pi right here, but that's wrong. You just do this and get the number, and then you look for this in the C tables, and that's it. That's all you have to do. These ones are actually wrong too. So in here, as you can see, again, we have the squared 2 pi here, where in reality what we should have done is have the value that was given to us, which is x, written here, subtracted by the mean, that's right here, over the standard deviation, that's right here, which gives us this quantity. And then you look this quantity in the C tables, and it gave us this result. And this is the actual result of the problem that we had. And this is wrong. As you can see here in problem number 3, we again have the 2 pi, which is wrong. And the correct way to do it is that we're given these two numbers, and they're asking us what's the probability of the number being between these 2 quantities. So what we do is again the same. We have our x value over here minus our mean over our standard deviation, and then we get the result. We look in the C tables, and this is what we get, and you do the same for the other value, which is right here. And then you subtract the smallest number to the biggest number, and this is our final result.